Welcome to all. I'm the course coordinator of Test and System Design. Today's topic, decoders. So at the end of this session, you'll be able to understand what is meant by a decoder, what are the applications of the decoder, how to construct a higher order decoders by using a lower order decoders, what are the applications of the decoders. The decoder is a combinational circuit which has an n inputs. We'll get a maximum 2 per n output lines. So let us take it as an n inputs and m outputs. M outputs are a 2 per n output lines. So one of these outputs will be active or high based on the combination of inputs present here. When the decoder is enabled, it will give an output, the corresponding combination of the inputs. That means that the detector detects a particular code, the output of the detector are nothing but the minterms of the n input variable lines when it is enabled. So let us consider take the example as a 2 to 4 decoder. That 2 to 4 decoder means it is having a inputs of 2, outputs of 4. Having the inputs of A1, A0, outputs are Y0, Y1, Y2, Y3. The block diagram of the 2 to 4 decoder is this one. This is an enable input. Enable input is used to enable this decoder. The outputs of the decoder will, if the enable input is 0, whatever the inputs are present over here, then it will not reflect the output. So that the output will be equal to 0, 0, 0. If the enable input is high, then only the input combination will reflect the outputs. So if the enable equal to 1, if the inputs are 0, 0, then it will give the equivalent value for this 0, 0 code. So that we'll get a high output at Y0. For 0, 1, we'll get a high output at Y1. 1, 0, we'll get a high output at Y2. 1, 1, we'll get a high output at 1, 1. So this is the truth table of 2 to 4 decoder. From the truth table, we can write the Boolean functions for each output as Y3 equal to enable pin must be equal to 1, A1, A0, Y2, A1, sorry, Y0, E into A1 bar, A0 bar, Y1, E into A1 bar, A0, Y2, A1, A0 bar, Y3, A1, A0. So this is the Boolean logic expressions for the Boolean functions for the decoder 2 to 4 decoder. The logic diagram for this 2 to 4 decoder is the inputs are given to the AND gates. Why? Because all the outputs are nothing but these, all the outputs are equal to the minterms of the 2-bit combination. So if the 2-bit, if there is a 2-bit, there is a 4 combinations will occur. So the 4 combinations will given a 4 minterms. And Y0, Y1, Y2, Y3 as the 4 minterms. These are the outputs of the decoder. The enable bit must be equal to 1, so that we have to apply the enable bit for all outputs. Then only it will give an output. So the enable is an active high enable E. Then for 0, 0 combination, 0, 1 combination, 1, 0 combination, so that we have to apply in a A0 and A1 both are in a complemented and uncomplemented form. For this complemented form, we have to apply an inverter. For that, A1 is applied for the inverter, A0 is applied to the inverter. So see here, Y0 is an E into product with A1 bar, A0 bar. So Y0 is an output of an AND gate. AND gate is used to product the literals. So E multiplied with A0 bar multiplied with A1 bar. Y1 is E multiplied with A0 multiplied with A1 bar. Y2 is E multiplied with A0 bar multiplied with A1. Y3 is multiplied with E, A0, A1. So that is a 2 to 4 decoder. The next one is implementation of higher order decoders. The first decoder is a 2 to 4 decoder. The next decoder is a 3 to 8 decoder. That will be in a higher order decoder for a 2 to 4 decoder. So we can construct a 3 to 8 decoder by using a 2 to 4 decoders. So 2 to 4 decoder is having a 4 outputs. 3 to 8 decoder is having a 8 outputs. To attain a 8 outputs at the output side, we require two to 4 decoders. One 2 to 4 decoder for 4 outputs, 2 to 4 decoder require 4 outputs. By adding these two, 4 plus 4, 8. So we require 2 to 4 decoders to construct a 3 to 8 decoder. The first decoder is having a 2 inputs, the other decoder is having a 2 inputs. We will connect those two decoders to attain 3 inputs. See here. In this section, let us implement a 3 to 8 decoder by using a 2 to 4 decoders. We know that 2 to 4 decoder has 2 inputs, 4 outputs. 3 to 8 decoder has 3 inputs, 8 outputs. We can find the number lower order decoder required for implementing the higher order decoder. Using a requires a formula. Required number of lower order decoders are M2 by M1. M2 means 8. M1 means 4. So 8 by 4. We require 2 to 4 decoders to construct a 3 to 8 decoder. This is a block diagram. 2 to 4 decoder, 2 to 4 decoder. If I apply an invert, if you here I'm applying a A0, A1, A2. So A0, A1 lower LSB A0 is applied to a down decoder. A1 is applied to the down decoder. These two LSB bits are applied parallelly to the another decoder. The MSB bit must be applied to two decoders. One, it is applied to the upper decoder directly. For the lower decoder, it has to invert. It has to apply through an inverter. So for an upper decoder, it is applied to the directly. For a lower decoder, it has to applied through an inverter. So like this only we'll get an 3 to 8 decoder. So for a 3 inputs, A0, A1, A2, the lower two LSBs are directly connected to the two decoders. These two inputs are directly connected to two decoders. The third MSB bit should be connected to the upper decoder directly. Lower decoder, for this lower decoder, we have to apply this MSB through a inverter. So let us consider a one combination. 0, 0, 0. The MSB is 0, middle bit is 0, LSB is 0. So 0, 0, 0. So that for a 3 to 8 decoder, we should get an output at Y naught. So let us check 0, 0, 0. So two decoders is having a 2, 0, 0, 0, 0. So this A2 will act as an enable pin. So here A2 is directly given to this upper decoder. So that here we are having a 0. So here we are applying this A2 to a A2 complement to this lower decoder. So 0 is complemented, then we'll get a 1. So the enable input for the upper decoder is 0. The enable input for the lower decoder is 1. So if the enable input is 0, whatever the input is present, the output is 0, 0, 0. Here the enable input is 1. Then if it is inputs are 0, 0, where we'll get an output? At Y naught. So here we'll get a higher output 1, 0, 0, 0. So the complete one is 0, 0, 0, 0, 0, 0, 1. We'll get only output at Y naught. For 0, 0, 0, we'll get output, higher output at Y naught. For 0, 0, 1, A2 directly given to this upper decoder. A1, A naught, lower decoder. 0, 1 means it always enables the Y1. So that we'll get an output at Y1. 1, 0, we'll get an output at Y2. 1, 1 will get output at Y3. For this lower decoder, for these 4 combinations, the lower decoder will act will act, the lower decoder is an active condition. For this next combination 1000. So 100 means the A2 is upper bit will be in a 1. The A2 is directly connected to the enable pin of the upper decoder. It is connected to the lower decoder through an inverter, so that the output of an inverter will be 0, so that the lower decoder will be in a disable condition. Then 100 means A1, A2 is 00. So whatever the inputs are present, if the enable bit equal to 0 means the outputs are 000. So the output of 2 to 4 decoder will be 000. There is no output from here. So here 1. So that it will generate an output based on the combination of two inputs. Here it is a 00. So that this decoder will given a high output at y4, so that we'll get an output at y4. 0 1 will get an output at y5. 1 0 will get an output at y6. 1 1 will get an output at y7. So for upper combinations we'll get outputs y4, y5, y6, y7. For the lower four combinations we'll get an y0, y1, y2, y3. So in this way we'll construct an upper higher order decoders by using a lower order decoders. This is a 4 to 16 decoder. So we can construct a 4 to 16 decoder by using a 3 to 8 decoders. Similarly, 3 to 8 decoder is having a 3 inputs, 8 outputs, 3 inputs, 8 outputs. So the complete outputs are the 16. So like this way, y0 to y15 we'll obtain by combining the 3 to 8 decoders. So lowest 3 bits are directly given to the applied to the 2 decoders. The uppermost bit, MSB bit, will be acts as an enable input for a 3 to 8 decoder. 3 to 8 decoders 1 and 2. So for MSB bit is directly given to the upper 3 to 8 decoder. It is given through an inverter to a lower decoder. So similarly, as in the 3 to 8 decoder, we'll get the same output in a 4 to 16 decoder. Thank you.